laser pointer. Anything else we need to talk about, or should I just get going?
We're good. Yeah, I think we could just get cracking and hear what's going on and see what kind of discussion we.
Okay, great. Little funny thing here, seeing as Halloween's coming up and Milky Ways and Mars bars are a favorite, it seems. But moving on. So as of yesterday, in the exoplanet counts, we have 4,521 confirmed exoplanets and about 5,000 other that are waiting to be confirmed. They have to have more than one source, and the source has to be really looked at and made sure everything's fine. So most of there's four main ways of finding exoplanets. The transit method is when you're looking at a star and a planet goes in front of it, and the brightness of the star dims a little bit. That's how most of the exoplanets have been found, and most of those were found by Kepler, the space telescope that went up in 2009. So of these 4,500 planets, almost 75% found by the transit method. If a planet is orbiting a star, it tugs on that star and makes it wobble a little bit. So we also can find planets by radial velocity. The very first planets were found that way, but now only about 20% of the other ones. And there's microlensing and imaging, imaging is just taking a picture of the planetary system, and microlensing is using gravitational lenses, but I won't go into all that. So this little chart is kind of fascinating. It puts on the bottom x-axis is the orbital period in days. So we go from just hours to 1 day, 100, it's logarithmic, so it goes up very quickly. And on this side is the planet mass, with Earth mass being 1. And we can see that there have been very large planets that orbit their stars very quickly in the matter of hours, which was quite a surprise. But here's all the planets that were found by the transit method, and here are all the ones found by the radial velocity method.
So those ones that are going around their planets that fast, like
Yep.
They must just be going at an incredible rate. Like, would they be able to have an atmosphere? Or would they be breaking up as they're kind of going around?
Found some of both. If they get too close to their star, they certainly can break up. Being that close often means the solar wind from the sun is blasting the atmosphere and stripping the planets of it. However, there's lots of very stable planets, large planets going around stars. And these are the stars, the little M dwarfs, so very small stars with big planets, very close in, and they're quite in stable orbits. Most of those will be what's called tidally locked. So the same side of the planet always faces the star, which means that that side of the planet's going to be roasting hot, and the dark side of the planet's going to be freezing cold. Not very good to look for life there, except right at that sunset and the terminator, right where it's the day going into the night. There might be some favorable conditions for life. Not a lot of life, probably not evolved life, but life.
That's cool.
And Mars and Perseverance and Ingenuity. So they landed on February 18th. So here's the Perseverance rover, and here's the little Ingenuity helicopter. Helicopter was just a demo technology, and they were really hoping that they could get 5 flights in. Well, it's just finished its 14th flight. It's well past the checkout phase and is now actually flying around and scouting out spots for Perseverance to go to. Flying a helicopter on Mars is very tricky. The Mars atmosphere is only 1% of the Earth, so the helicopter had to be very light. It's just around 2 kilograms, and it has to have very long rotor blades. So they're 1.2 meters, and they have to spin very quickly at about, at the surface, they have to spin about 2,400 RPMs. And you have to be careful because that means the tips of those rotor blades are going around really fast. At 2,400 RPMs, the tips of the rotors are going about 152 meters per second, which is 63% of the speed of sound on Mars. It's hoping to go into higher flights, which means it has to spin faster at about 2,800 RPMs. And that's getting to be almost 75% the speed of sound. You can't, you don't want to spin those tips so fast that they're breaking the sound barrier. That would probably absolutely destroy the little guy. But NASA has absolutely proven the helicopters can fly at Mars. Percy has traveled a total of 2.6 kilometers. Here's the landing site, and it's going down this, looking at everything. That's where both Percy and Ingenuity are right now. Perseverance has collected 2 core samples and dropped them off. Those hopefully will be returned to Earth in the early 2030s. Also in February, 2 other missions. India sent an orbiter, which is looking at the atmosphere of Mars, and China sent an orbiter, lander, and rover. China's first mission to Mars, very ambitious, and everything worked out, so good for them.
Is that the picture that you have there, is that off of a website that you follow? Like, where are these guys? Like,
that's, oh, this one?
Yep.
Yeah, that, just go to NASA website and
Yep.
everything is there. Or you can even Google Perseverance and it'll bring up, because it's a bit of a combination between NASA and European Space Agency, I think. I'm getting, there's so many rovers and stuff going around. I'm getting a little confused about that, but yeah. Now, right now, we're in a 2-week silent period with Mars, because Mars and Earth are on opposite sides of the sun. So all the equipment is still gathering data, but there's no transmission. So there's no instructions going up and there's no data coming down. So this is also a consideration for any planned human habitations on Mars. There's once a year, there's going to be about 2 weeks where you cannot communicate. Just more fun things to think about.
That's cool.
Oh, and here's little Ingenuity's first flight popped up. Actually, this might be second because it jiggles a little bit back and forth, testing to see what it can do, and then pop back down. It only went about 3 meters high. Excuse me.
Man, you would think the engineering involved in that, to, the friction, right? You just moving at that speed, like.
Yeah, well, there's not a lot of friction. That's the problem.
Well, yeah.
The atmosphere is so sparse that you have to get those propellers going really fast to be able to push it down to get your height.
No, I mean the friction on the machine of, a part moving around that quick.
Oh yeah, absolutely. And it's very often dusty on Mars, so you have to make sure that the moving parts aren't getting clogged with dust and stuff like that. It's solar operated too, so it takes 1 day to charge up and then it'll fly kind of the next day, sort of thing. So all different considerations. Okay, what's now? There's also the InSight lander on Mars, and this little thing right here is a seismometer. Now, we had always thought Mars was fairly volcanically dead, not a lot going on. But this little guy just measured a Marsquake magnitude 4.2, which on Earth, you would definitely feel the rumbling. And the horrible part, or the interesting part of it, is it lasted 90 minutes straight. If it did that on Earth, even 4.2, it's not a huge earthquake, but if it went for 90 minutes straight, it would cause a lot of damage. And this Marsquake happened 8,500 kilometers away, and it was still able to measure it. It's measured a lot of smaller Marsquakes, but this is the largest and the most distant that it's ever detected. So there's still internal stuff going on in Mars, cooling, shifting. There might be some magma or something lower down that's shifting places as it cools. So,
And didn't that used to be a hypothesis about Mars, was that it was kind of, it didn't have any tectonic movement, and that's probably why you couldn't inhabit it?
well, it probably never had tectonic plates.
Oh,
It cooled too fast for all that to get set up. But I mean, we know that it's been volcanically active because there's huge volcanoes. The largest volcano in the whole solar system is on Mars, Olympus Mons. It's 3 times higher than Mount Everest, and it's just this 500 kilometers across at the base, just this huge volcano.
wow.
So we know in the distant past is volcanically active, but recently not thought to be at all. But there is still stuff going on inside Mars as it cools.
So would they have, I guess it's a bit different, but would they have this similar type of rocks?
Yes. Now, rocks on Earth went through, as Earth differentiated, the nickel and the iron went to, because of the most dense, they went to the middle. We had this mantle, and the lighter rocks, the granite is what makes the tectonic plates. They're light, so they float above all the other kind of rocks and the mantle is kind of a plastic sort of thing, and so the granite fits about there. Mars did differentiate. It does have a core, but it didn't quite, it's much smaller, so it cooled faster, and it didn't differentiate in the same way. It didn't get those convection currents of granite coming to the surface. Inspiration for space tourism. This was SpaceX. It was the first space tourism flight, completely autonomous. That means the launch, the orbits, and the landing. It launched September 16th with 4 civilian crew and spent 3 days orbiting Earth. And you can see here, it was actually at a higher orbit than the Hubble. So here's the Earth. The ISS is about 400 kilometers. The Hubble orbits at about 540. And just above that was the SpaceX. That's the farthest humans have ever orbited in space. Now, I say it was totally autonomous, and it was. The civilians on board did not have to do a thing. However, 3 civilians were flight pilot or jet flight pilots. So I'm not even sure if they could do anything, but they certainly understood what was going on with everything. And one really cool thing is, so this is the nose cone that flips back if it's going to dock at the space station. Well, instead they put a transparent dome over top of it so that the civilians could have a really good look at the Earth or whatever else. So here's one of them looking out through this dome.
Wow.
That would be amazing to see that. Yes, yes. I mean,
they're on one of those?
Pardon me?
Are you going to get on one of those, Colleen?
Absolutely not.
No.
Never, ever, ever.
You wonder, like, they just say civilians, eh? Like, is it just random people off the street, or how do they decide who gets to go?
Well, this guy here, he's a multi-billionaire. And about a year ago, he and Elon Musk were talking, and he said, if you ever get to a civilian thing, I could do that. So he banked the whole trip. He paid for everybody's flight. He paid for everything associated with this flight, which I have no idea how much it costs, but a lot. And then he switched it around and they did a fundraising for St. Jude's Hospital, Children's Hospital. And one of the people, this woman here, I believe it was, yeah. She was 19, the youngest person to ever go into space. She was actually a patient at St. Jude's. She has an artificial limb, so that's another first artificial limb sent out into space. And they raised millions and millions of dollars. So he floated it by Elon saying, I got the money, let's do this when it's available. And it became available. But it certainly means that it's possible for more of these to go up. Elon plans on sending a ship around the moon. It's not going to land on the moon. It's just going to be out to the moon, around and back. And that's going to be paid for by somebody else, a private investor or a private guy who is raffling off tickets, I think, for it. Yeah. So great step forwards that this can all be done autonomously. It's amazing considering the computers that were available for the Apollo spacecraft, which anybody with a calculator now has more power than they did. So the technology is amazing. And another first for SpaceX, this was SN15. So these were test launches. The craft launched, went to about 10 kilometers in space, did a belly flop, came down through the atmosphere, started its engines again, went upright, and then landed back at the site. Amazing. It took 3 or 4 times. The previous ones kind of blew up, but this one made it, so it stuck the landing. And Elon's also seeing this for Mars and the moon. NASA has given SpaceX the contract for landing people on the moon from the Gateway project, the space station orbiting the moon, and he's going to probably be using these kind of ships. Not to be outdone, Jeff Bezos, Blue Origin, did another completely autonomous space tourism thing in April. And of course, Virgin Galactic had to get in there too, Richard Branson. They have a bit of a different way to do it. They have a big plane and then the space part of it is underneath. So the plane takes off, gets up to, I forget how high, 80,000 feet or quite a distance, drops the space part off that then starts its rocket and shoots up into space. And they got a few minutes of free fall, microgravity floating around. As far as we know, this is just going to be for space tourism also. Although they could do a few very short-lived experiments on that if they wanted to. Finally, the James Webb Space Telescope is hopefully finally launching on December 18th, 2021. And it launched from Earth, and then it will go to a place called Lagrange 2. So whenever you have 2 bodies orbiting each other, 5 places are naturally come out of the gravity where the gravity is sort of canceled out. So it's really easy to put a spacecraft there, and it doesn't take much energy for them to stay there and orientate. It's about 1.5 million kilometers from Earth. On its way out there, it'll unfold because it had to be all folded up to get into the rocket, to get it into space. So first comes the sun shields. It's about 5 layers that will face the sun. So the sun will not be able to heat up any of the instrument, including the mirror. And once the sun shields are unfolded, then the telescope unfolds like that.
How big is that?
Oh, it's huge.
Huge. Like when it folds out those sun with shields. Like, is that like, are we talking like absolutely massive, or is it just like the size?
Well, the mirror itself is 18 meters across.
Wow.
So it's huge. Yeah. Yeah.
Wow.
It's the bigger mirror you can get, the more photons of light you can capture, the dimmer objects you can see, and dimmer objects are usually farther away. This is going to complement Hubble really well because it's going to be seeing in the infrared. Now, you and I have infrared sensors on our skin. It's just heat. So this telescope is going to look for heat signatures. It will be able to see back in time to possibly within 100 million years after the Big Bang. And this is when the first stars and galaxies were forming. So it's very exciting. Now, you probably all heard about Hubble's problem. When it first launched, the mirror was not right, and they had to redo it, not redo the mirror. They had to send up what essentially were glasses to fit over the mirror so it could get sharp images. The really cool thing they've done with this space telescope, because being so far away, it's never going to be visited for any kind of upgrades or fixes or anything. Each of those mirrors, so you can see their hexagonal mirrors, each of them can be deformed. So they'll be able to tune it perfectly to get great images. And it will also be used to study exoplanets and their atmospheres. So that's going to be a really another thing on the way to looking for life in the universe.
Do you think, like, is this telescope gonna really change our understanding, like, of, I guess, of the universe? Is it gonna open our eyes, and so, like, do you think we're gonna find things that we just didn't know about?
Absolutely. And I say that not because I have any knowledge about it, but because every time we've sent something in, a new telescope has shown us things we never even thought of before.
Right.
So to be able to look back to when the first stars and galaxies were forming, that's going to be an amazing step to our understanding.
This is the biggest step in space understanding in like a long, long time.
Yeah, yeah. I would put it right up there with the being able to measure gravitational waves. This is huge. So, and like I say, most times we don't even know the questions to ask.
Right.
Once
Right.
yeah. So it's going to be amazing. And like I say, finally it's getting into space. Years over time, billions of dollars over budget, but it's getting there now. So we're all happy.
Nice.
China also has a space station now. This is a look at what it's going to look like when it's finished. It's right now, it's just sort of the center part. And these three fellows have spent 3 months there. So it's viable, it's working. If you saw the movie Gravity, Sandra Bullock can't get into the space station, but she sees the Chinese one off, so she pushes herself off to that. Yeah, that's an impossibility. So don't think that there's going to be astronauts flying between the two space stations. But
Gravity wasn't your favorite movie, Colleen?
only eclipsed by Interstellar. Yes, I think I've said that often. The two worst movies I have ever seen. If you like them, fine. But
I remember you talking about Gravity, but I don't remember your take on Interstellar.
oh, Interstellar, yeah. I'm really I really like Gravity, and I study it a lot, and I see how it affects everything, and we still don't know exactly what it is, and I find that all fascinating. But apparently, as quoted from Interstellar, the only thing that can translate across time is love and gravity. No, just wrong. But anyway,
So that just ruins the movie.
it just completely ruined it for me. Yeah. But I have no right side brain. I'm totally left side brain. moving on. You may have heard about this comet. It's the biggest comet that we have ever seen. It's about 160 kilometers across. Most comets are like in the 5 to 10 kilometer range. This has come from deep within the Oort cloud. The Oort cloud's a spherical shell around the solar system going out to, maybe a light year, and filled with billions and trillions of comets. And this one is heading in towards the inner solar system, well, the solar system. At its closest approach, it's going to be just outside the orbit of Saturn. So here it's coming in this way from underneath, and it's going to go up over top of the solar system. And its closest approach to the sun will be just outside Saturn. And that's going to happen in early 2031. It has an extremely elongated orbit. So it stretches from here out to probably a light year away, taking about 6 million years to go around its orbit. It's probably going to be perturbed enough by Saturn and Jupiter, the solar system as a whole, the inner solar system as a whole, that its outgoing trajectory will take it on an orbit that will never come back. It'll just head out. And there is some talk, which is really exciting, about a space mission that will go and intercept it. The European Space Agency is building a probe called the Comet Interceptor, and it's going to be designed to investigate comets coming from deep space. So it or something like it might be able to visit this comet in about a decade from now. That would be amazing. This is primordial stuff that formed as the solar system was forming. So again, lots of information from it.
We send Bruce Willis to blow it up.
No.
Who's it named after, this one?
This one is the two astronomers that discovered it.
Oh, okay.
Bernardinelli and Bernstein. And they discovered it in 2014. But you have to look at anything very carefully and multiple observations to be able to get its orbital parameters. So it'll still be looked at and might be adjusted, but as far as we can tell right now, that's going to be its closest approach. It's going to be an amazing thing. Not naked eye, but still amazing.
Yeah, no, it could be like a preemptive big box movie right there.
Don't get me started on that. And moving on to asteroids, the space probe Lucy is going to launch October 16th, and it will visit 8 different asteroids over a 12-year mission. One of the main belt asteroids, which are the asteroids between Mars and Jupiter, and 7 Trojans, 4 of which are binary systems. So these asteroids are thought to be remnants of the primordial material that formed the outer planets. So it's going to be really interesting to have all these things found. Now, remember, I just talked about Lagrange 2, where James Webb is going to be. So these 5 spaces, so if this was Jupiter and the sun, it would also have its 5 spaces where gravity is kind of canceled out. And we get a buildup of asteroids. So this is L4 and this is L5. And if an asteroid kind of drifts into it, it is kind of stuck there, and it'll just precede Jupiter or follow Jupiter around on its orbit. So those are the asteroids that are going to be studied. So Lucy is going to launch from Earth and get one Earth kick to send it into a more elongated orbit, and then come by and get another kick from Earth, which will send it out to these L4 Trojans. And there's a bunch there that'll study, including the binaries, which will be awesome to see. Then it'll come back in towards the Earth and get another gravitational boost to send it out to the L5 Trojans and study them.
That's
So
amazing. That's crazy.
yeah, you can't send enough fuel on these missions to do this. You have to use the gravitational push boosts that they get from other planets. Is that all?
So this, when they're looking at these asteroids and like that, like what are they, like they're looking at, I guess, kind of back in time when these things formed, you know, probably a long time ago. So I guess, is it another one of those cases that they just don't know what they're looking for, or is it they're curious what the composition was around at the time? Like
Yeah,
what elements were there?
yeah. The only asteroids we can kind of study are meteorites that land on Earth. So to actually be able to go to an asteroid, I should say though that asteroid in the past years, two space stations, one from Japan and one from the NASA, have actually gone to asteroids and scooped up stuff and brought it back to Earth. The Japan one landed last December, I believe, and the one from NASA is on its way here, but it's going to be a year or two more before it lands. So that's the only kind of small little bits that we've been able to study. So to be able to study them in situ, and I'm sure it'll have spectrometers and all this kind of stuff, so it'll be able to tell exactly what these things are made out of and how old they are, probably from the formation of the solar system, so 4.5 billion years ago. It may lead to, you know, a better understanding of why Earth is inhabited, and all sorts of wonderful things. And again, we're going out there with certain questions, but we're sure to find, you know, things that we never expected, never even knew to ask.
And I would imagine there would just be such a multitude of different ways that these asteroids would have formed, right? You know, depending on where they came from and, you know, yeah.
What part of the initial huge cloud they were in to form. Yeah.
Huh. Cool.
Yeah, it's amazing. It's really amazing. And something I just found out today, Bepi Colombo is going to do its first Mercury flyby. It will eventually orbit Mercury. This is from the European Space Agency. So he gets first Mercury flyby today. Getting stuff from Earth to either Venus or Mercury is really, really hard. You have to give whatever your rocket enough boost to get out of Earth's gravitational pull, and then send it in towards the sun, which means it's going to keep increasing its speed. So you have to actually slow down. And again, you can't send enough fuel to slow down. So you use gravitational boosts. It's already done one by Earth, then two from flybys of Venus, and now it'll do 6 flybys of Mercury before it can get into orbit.
Wow. Now, how much control would people, do they have any, how much control do they have of it to make changes if something happens? Like, or is it all, it's set in motion and
it's pretty much set in motion, and we know all this from Newton's laws of gravitation. It, you know, it's very precise. They did just make a small course correction, I think it was yesterday, and that is built into it because it's very fine-tuned, the gravitational pulls and boosts and things. So, you know, actually when it goes around Venus, because Venus is rotating the opposite way, it actually slows down. So that's even, you know, we know that happens, and all these gravitational flybys are precisely what Newton said they were going to be, with a little bit of, you know, course correction if needed. Not very much though. And that is all I have to say for today.
That's amazing.
So
Yeah, so yeah, they still using like Newton, super important, right? For
oh, absolutely, yeah. I can't get back to my thing. Why can I not get back to my? Okay, I just had to do some manual adjusting here. There we go. So I'd love to hear what your questions you have or what you would like to talk about in the next chats that I can look up and find out things for you.
yeah, sure. I guess we could just do a little, just go around and see what they kind of took away, or some things that kind of they blew our minds when we were watching this, and then we'll
There we go.
see
That's
what
better.
people are interested. Caden, you want to start us off with something that you kind of like, whoa?
Okay, so I kind of have one thing that I kind of want to like say that I found interesting, and another thing that I kind of like asking.
Good.
So the thing that I'm kind of interested in is how fast the Ingenuity is spinning on Mars. Like, Jesus, I didn't realize that was spinning that fast.
Yeah, yeah. And it can't go much faster with those rotor blades, or it's going to have problems with the speed of sound.
With sound barriers, the entire thing is just going to turn into a puddle of dust.
Yeah, yeah.
And a thing that I wanted to know is, isn't gravity just like mass?
Sorry, gravity is.
Isn't gravity just like mass?
Is a mass. He said it's in gravity, mass.
So it means the more mass you have, the more gravity you have.
Gravity seems to be an intrinsic part of the space-time fabric. And if a mass is within that space-time fabric, then gravity pulls space-time into it. You'll often see it, a stretchy piece of fabric, and you put a ball on and it, goes down. That's a good 2D way of explaining it, but gravity is pulling space-time towards it. And that affects the motion of anything going near it, including light.
Oh, I love space so much, but why is it so confusing?
Sorry, I can't.
He says he loves space so much, but why is it so confusing?
Should I do a thing on gravity?
Yeah.
Yeah.
Okay.
Yeah.
Right.
Jacob, what'd you think? What was your takeaway?
I mean, I really enjoyed hearing about Mars and Perseverance. That really sparked my interest. And
Good. Yeah.
I have a question. How fast is that asteroid going? Or comet?
How fast? Well, I do not know. That big comet, you mean?
Yeah.
Yeah. It will go fastest at its closest approach to the sun, but I do not know how fast it will go. There is a speed limit of the solar system. If you go too fast, you get flung out. And that's how we know that we've seen one asteroid and one comet from different solar systems, because the speed they were coming into our solar system was too fast for anything within our solar system. So we know that they had to be coming from somewhere else.
Is there any way for anything to pick up speed within our solar system? Like, what if something like was like going around a black hole? Like, just thinking of those using Newtonian physics to send those things out to the things out to the planets, right? To do the circle around. Like,
Yeah.
could meteors do that type of thing, going around black holes and things and pick up speed?
All orbits are ellipses, so they're not circles, they're ellipses, with the main the more massive thing at one of the foci of the ellipse. So as anything, so I have a little sun here, and I have a little planet out here. As that planet is farthest away, it's going slowest.
Yeah.
And as it starts coming in, it's the gravity of this object is making it speed up, and then it whips around and goes out again. I have a great sequence of pictures of one of the stars that is orbiting our black hole at the center of our Milky Way galaxy. And that's exactly what it does. It's slow, and then really whips by. And because the black hole is so massive, it really pulls that thing down, and it's going a fair percentage of the speed of light as it whips by the black hole. So you can, yeah, definitely. And that's what those gravitational boosts are for. The probe, whatever probe, like you say, you can't send enough fuel. So you send a probe to, say, Earth, and no, let's not use Earth because we're Earth. The Voyagers were a perfect example. As they came by Jupiter, let's see, how am I going to do this? They get really close to Jupiter, and they actually steal some of the momentum of Jupiter and then end up going faster. If you go around Venus, which is rotating the other way, you can slow down. You can change your direction. So it's like pinball. You have all these things out there, and you have things bouncing, around in between them.
Yeah. Wow.
Again, just by using Newtonian gravitation.
Cool. All right, Dill, we'll go, just get to Dill, and then we'll come back to your question.
Well, I kind of just found the whole Mars thing in general, that was pretty neat, because I think that's a neat idea that we might move to different planets sometime. And I like to look into that.
Yeah. Speaking, like, Elon Musk has a plan to set up a colony on Mars. And apparently Grimes, even though they're broken up now, she plans to die on Mars. She wants to go to Mars. And really, when you think of Mars, because it takes, 6 to 9 months to get there, and then you have to be there at least a year before you can even consider coming home, 6 to 9 months. It's going to be more like the Mayflower. You're going to get on the ship, and you're going to go to Mars, and you're going to stay at Mars. You will become a Martian. There's probably not going to be a lot of this, two-way traffic back and forth.
Wow.
Yeah.
Yeah, that could be, would people be interested in learning about that? Like how, like the colonizing other places and how the ideas that are out there?
Sure. Colonizing Mars.
What about the movie Martian? Did you like that one? That seemed like a pretty good one.
I loved that one.
Oh, yes. Okay, good.
And if you like that one, you should also read Artemis by Andy Weir and Project Hail Mary. Amazing books.
All right, cool.
Yeah.
What did you think, Brett?
I thought it was all just mind-blowing as usual, but the thing that got me wondering is all space stuff and technology, is it just money? Is it money? Like, because these rich guys can make things happen so fast compared to when governments are in charge of it and everything. So like, they're breaking barriers all the time with this technology. So if everybody worked together, like, where would we be?
That would be amazing. Of course, NASA is spending the public money, so they have to approach everything much more cautiously.
Right.
Where SpaceX, they have 3D printer things, and if you have an idea for a better cog, you just print it up and try it. Where NASA, it could take up to 10 years to go through all the regulations. So yeah, private enterprise is certainly increasing the rate of technological developments.
Right.
Like with the space tourism, would you think that would outweigh the technology that's being invented? I guess it's kind of outweighing the environmental costs, right? It's kind of, we're at a bit of a balancing act with some of it, depending on how long it goes on for.
every aspect of your life today has been influenced by technology developed by NASA or the European Space Agency or these private companies, every single thing. So the rewards are amazing to get out of it. And just pure science, it needs to be done.
Kate, you had a question?
Oh yeah, and why do all the planets in our solar system go in like a fixed way, fixed pattern? Like why are they all in the same plane, going
Okay.
in the exact same direction?
Yep.
Except one isn't.
One's on
It orbits the sun the same way, it just rotates differently. So things like the solar system start off with these huge clouds. I can't even 400 light years across or something like that. And they're clouds of dust and gas, hydrogen, helium, some stuff from stars that have already blown up and made heavier elements. And they're kind of just sitting there, and something will cause that cloud to collapse. It might be a supernova blowing off and the pressure wave hitting the cloud, or it might be going through the density arms, the spiral arms in the Milky Way. And something will cause that cloud to start collapsing. And so gravity will start pulling little bits together, and little bits become bigger bits, and the bigger they get, the more they can pull. So there will become sort of an area of that cloud that has the most gravity, and it'll just keep on feeding in. Now, there will be a general motion to that cloud. And as you know, you've all heard the ice skater, you know, doing a twirl, arms out, they go slow, arms in, they go faster. So that starts happening too. All this stuff starts going in towards this center of the gravitational pull. And because there's a spin, all that stuff flattens out into a disk. Now, not all of it does, because remember that Oort cloud that is right at the edge of the solar system. So there's not enough gravity from our sun to pull those really any closer. But the rest of the solar system flattens into the disk. So now you have a star in the middle and a dusty disk orbiting it. And within that disk, you'll start getting little gravitational attractions, and they'll start building up and they will form planets. So everything's going around the same direction. Say if you're looking down on the sun, everything goes in a clockwise or counterclockwise direction. Now, as all those planets are forming, of course, they're forming in a disk that's moving, so it has some momentum. So they form and they rotate in the same way, except for Uranus and Venus. Uranus actually rotates on its side. It kind of rolls around. It was hit by at least maybe one or two things during its formation that tipped it over. And Venus in its history developed this really thick atmospheric layer. It's 90 times the pressure on the surface of Venus than it is on Earth. Whoa. And that pressure, that atmosphere, has actually slowed Venus's rotation down and made it start going the other way.
Would that, if we were there, so we'd be 90 times heavier?
No, not the gravity, the atmospheric pressure.
Oh, the pressure.
So the surface on Venus is the same pressure you would feel at 1 kilometer down in sea level on Earth. Yeah, that's why we haven't visited. Right. We haven't visited Venus a lot, because the Russians tried a lot of time, and every time they sent something there, it would crush because of the extreme pressure there.
Wow.
Yes.
Cool. So this is just hypothetical, because this is basically impossible that this will happen. But what if all of a sudden Earth just started rotating in the complete opposite direction of all the planets?
If Earth just stopped and started going the other way?
The orbit would just like turn in the other.
Like, how would that affect other things, or
how would that like affect us and the solar system?
Earth is rotating pretty quickly. At our latitude, we're going 1,000 kilometers an hour towards the east. So imagine that stopping. You would be flying through space at 1,000 kilometers an hour.
Right? It'd be like a car getting in an accident, I guess.
Yeah, just
Stopping
stop.
all of a
And
sudden.
now if you could magically just make the Earth stop and then go back without any problems like that, there would be a lot of things happening. For instance, Venus, its day is longer than its year. So that would happen to Earth also. So you would have a lot of heating on one side of the Earth as it slowly rotated and went and orbited the sun. So that, I think, probably might be the main thing. The Earth would just heat up tremendously.
I meant like not really the spinning, but the full orbit around the sun. Like what if it just went in the opposite direction?
Opposite direction. Now, as the solar system was forming, there probably were things that were going in the opposite direction. The main direction would be, counterclockwise. There would be some things going the other way just because of the mechanics of gravity and angular momentum. But you don't see any now because they probably smashed into each other. So the overall angular momentum of our solar system is a counterclockwise rotation. Like that, the big comets too, and things from the Oort cloud. Being that the Oort cloud is a big sphere, when anything gets perturbed out there and starts falling in, it could come from any direction. Like that big comet is actually coming from underneath the solar system, the inner solar system and out. Halley's Comet goes around differently, goes around opposite. So there are some things that happens, but most of the things that did that early on just smashed into other things.
When you talked about, you're talking about like a star form or planet formation. I guess earlier today we were talking with, we were looking at geology and anthropology and talking, human evolution, and you start dealing with millions of years, but human evolution, I guess, has changed, not quite, but how important is it to have an understanding of deep time to wrap our heads around these concepts? Because these things, they could take so long for a formation to happen, and just our time frame is just nothing.
I have an explanation for that in a PowerPoint called the cosmic calendar.
Okay.
Starting at the Big Bang, January 1st midnight, ending December 31st that year. And it shows you what deep time is like. So if you want, I can do that for you too.
Yeah, that sounds great.
Yeah.
Yeah, cool. Any other questions, Gay?
Well, that was pretty neat.
Yeah, that was very cool. Yeah, lots of knowledge. Like I'm surprised I missed. I knew that they sent that ship up and around, the one that Elon Musk's buddy was on, but
Yeah.
I wasn't aware of all the people on the flight. Like there wasn't, I didn't see much about it.
You weren't watching the same channels I watch.
Yeah. No, yeah. I'm surprised because I follow a lot of science sites and things like that.
Yeah.
But honestly, this is really cool because this is around like the first time that I've actually talked to like a astronomer expert, like actually like knows really well what's going on.
Yeah.
Do not call me an astronomer expert. I'm a universe enthusiast.
Experty.
Expert. All you have to be an expert is know something a little bit more than the person you're talking to. So.
Well, and curious, right? You're so curious about space. Are you always doing space stuff? Are you always space is on your mind often?
I do astronomy probably 36 hours a day.
Yeah. So what is it that do you have? So you follow all the different things that are going on?
There's so many. I'm getting, it's just amazing how much is going on. I'm gonna have to start narrowing my interests.
Do you have a particular thing that you find yourself thinking about most?
Gravity.
Gravity. Okay, good. So we're getting the one that you're thinking about all the time.
That amazes me, and I feel bad because most people have the wrong impression, the wrong ideas about gravity.
Right.
So I will do a short presentation next week about gravity, and then we can all understand it.
Awesome. Well,
Or sorry, 2 weeks from now, right?
2 weeks, yeah.
Right.
Well, thank you very much, Colleen.
You're very welcome. Thanks for
Our
asking me
applaud-
again.
Our applaud won't be quite as many this time, but
That's okay. It's okay. It's enthusiastic. That's all. I
still
care.
worthy. Still worthy.
Thank you once again for inviting me to do this. It's been great fun.
No, amazing to have you.
Okay,
Bye bye.
Thanks.
bye.